Hope everybody's doing well today. I want to welcome everybody to the Unimpressed Podcast, and I'm unimpressed that I haven't talked to this gentleman before. So I want to welcome Aubrey Gray to the Unimpressed Podcast. He's calling in from Silicon Valley. Yes, sir. How are you doing today?
I'm very well, thank you. Thanks for having me on the show.
Actually, the conversation we had before we jumped on here was about balance in the body. A good friend of mine, Dave Sandoval, is founder of Purium Health Products, and he taught me a lot about superfoods and how to utilize superfoods to balance your body and heal your body. Is there a linear thing here with something like superfoods and what you do and what you're going to try to prove to the world?
So, really, as with the whole of health and medicine and everything around how to keep people healthy, there is a spectrum between things that we can already do, but that only have a modest benefit, versus things that we hope will have a much bigger benefit, but we haven't yet figured out how to do them. So I'm at the latter end of that spectrum. I do research, and my team does research. We're interested in developing medicines that are much more beneficial than anything that exists today. But absolutely, our goal is exactly the same as anyone who works with superfoods or anything. We just want to keep people healthy however long ago they were born. And we understand that today there is a limit to how much you can do that. We want to remove that limit.
When you say remove that limit, what does that entail? Because if you look at things from a natural standpoint and you look at some medicines that may create an imbalance in the body, are these things that can be a combination of improving yourself? Is that kind of the direction? Explain that to me a little bit.
The critical thing here is to look at the problem from the point of view of an engineer, to remember that the human body is ultimately a machine. It's a really, really complicated machine, and of course it's a machine that we did not design, we don't have the plans, but it's still a machine, which means that at the end of the day, the functioning of the machine, whether it's our mental health, is determined by the structure of the machine, by what we're made of at the molecular level and the cellular level. Now, that means that we shouldn't be too mystical about, what's natural and, aging being this inevitable universal thing. Instead, what we should do is look at simpler examples that we can extrapolate from. And we have those simpler examples. So the one that I often like to use as a starting point is cars. Everyone knows, what a car is and how it works and so on. And we know that it is possible to make cars last a really long time. So there are cars around today that are more than 100 years old, and they're working every bit as well as when they were built. They didn't get that way by being designed to last 100 years. They were designed to last maybe 10 years. They had a warranty period, right? And they have completely transcended that warranty period. How? They did it simply because they got lucky with their owners. They were bought and owned by people who decided to do an unusually comprehensive amount of preventative maintenance on them, right? And that has been enough. That is all you need to keep the machine going just as well as when it was built. So our work is all about applying that principle to the human body.
What's on your plate today? What's the forefront?
There's no one thing. And the reason there's no one thing comes down again to what we mean by preventative maintenance. There's many different types of damage that even a simple machine like a car, accumulates as a consequence of its normal operation. And of course, a more complicated machine like the human body accumulates a larger number of different types of damage. And all of them, any one of them, can kill you, more or less on schedule, if it accumulates to an intolerable level, however well we fix all the others, right? So we can't take a single unitary view on this. We have to take a diversified view and develop a whole bunch of different damage repair medicines that we will in due course be applying to the same people at the same time.
This is something I said about the pandemic, right? I think we generalize too much. So when you talk about a vaccine, they're generalizing a vaccine. Instead of saying, all right, here's a group over here, here's a group over here, here's a group over here. And they know what each of these groups are made of. It could be age, body makeup, what have you, right? And based on these differences, that vaccine could have a different effect. Why don't we dive deeper and really understand that? And I think sometimes like these vaccines or whatever could be more effective putting that information out there. Why do we generalize things so much?
Because the degree to which we should be personalizing a certain type of medicine depends a lot on how well the medicine works. For example, let's take polio, right? Polio was a really big deal for a long time, and then starting maybe 50 or 70 years ago, we started developing ways to fix it. Today, we have polio vaccines, and we do not have personalized polio vaccines. Why not? Because we don't need them, because the generic vaccine just works. That's what you need. Those medicines can be optimized for particular people that have particular metabolic characteristics or ethnicities or whatever it might be. And certainly there's a huge amount of value during that period in ensuring that that's the case, that we identify the correlations between which tweaks match which people. However, we must never forget that that's a kind of stopgap. So when we apply this whole thing to my work, to the damage repair in aging, we're in a reasonably fortunate situation because everybody accumulates exactly the same types of molecular and cellular damage. Everybody. There are differences between people, but those differences only relate to the relative rates at which those types of damage accumulate. Some people will accumulate this type of damage a little bit faster than that one, and some people will be the other way around. And that's what different people exhibit, different age-related health conditions. Some people die of heart disease, some people die of cancer, and so on. But at the end of the day, when you're fixing the damage, which accumulates throughout life, just as in a car, rust accumulates throughout life, right? And all you're trying to do is eliminate that damage before it causes people to get sick, before it gets so abundant that it causes people to get sick. Then you don't really need personalization very much.
So what would you prevent right now?
Yeah, let me dig into some of the details. And I have to get a little bit technical here, but I'll try and do that as little as possible. So I'm talking all about, as you've heard, about the molecular level and the cellular level. So we're not talking about giving someone a new liver. I mean, sometimes that might be the right thing to do, but in general, it's at the more cellular, it's at the microscopic level. So the reason we feel that we know what to do is because people have been studying aging at the microscopic level for a very long time. And in fact, 20 years ago, when I first came up with a classification of the types of damage, one thing that struck me as a very encouraging point was that all of the types of damage that we knew about had been discovered at least 20 years before that. We had had a whole 20-year period of discovering nothing. And now it's 40 years. There's still no new thing. Of course, there are kind of variations on the theme, but there are no new, I haven't had to add a category or anything like that. So that's really good news. The whole, characterization of the nature of the problem is standing the test of time. One example of the type of damage that we accumulate is loss of cells. So, of course, each of our organs, each of our tissues is made of cells. There's a certain number of cells that the organ needs to be made of, in order to do its job. Now, in general, in most organs, when a cell dies, it's not a big deal, because what happens is that some other nearby cell divides to replace the cell that died, and so you're back where you began. But there are some organs that don't do that, where the cell dies, so that means, of course, the number of cells is reduced. I can give you an example of an aspect of aging which is like that, which is mainly driven by that type of damage. The best example is Parkinson's disease. So there's a particular part of the brain where we have a particular type of brain cell, a particular type of neuron called a dopaminergic neuron. And those neurons are very important. They create an important chemical that is relevant to how the brain works. And all of us have lost maybe a quarter of those neurons by old age, because it turns out that those neurons die much more rapidly than most neurons do. But some of us lose them a little more quickly, and we've lost maybe 3/4 of those neurons by the time we get to old age. And those people get Parkinson's disease. Mm-hmm. So it's easy immediately to see what we should do about that. We should simply replace the cells. And of course, you know exactly what that is. That's stem cell therapy. That's what stem cell therapy is, right? We produce cells in the laboratory and we prepare them into the right state so that they're the right kind of stem cell, so that we can then inject them and then know what to do. And that's already happening. In fact, it was first tried nearly 30 years ago. Back then, we knew almost nothing about how to manipulate stem cells. And so it was very hit and miss, and only a few people benefited in the clinical trials that were done. But the ones who did benefited enormously. They had completely no Parkinson's symptoms for more than a decade. It was just insanely effective. And now that we know a great deal more about how to manipulate stem cells and do this more reproducibly, we're all doing it again. So there's clinical trials going on right now to use stem cells against Parkinson's disease, and everyone's very optimistic. That's just one example.
I got two questions. The first question is, how is that operationally in the United States today? Because I know there was some things that needed to be passed and so forth. What's going on with that?
So you're quite right to remind the audience that there was a big political controversy about stem cells a couple of decades ago. And indeed, a law was passed to prevent federal funding for such work. But it wasn't all stem cell work. The only thing that was prohibited for federal funding was work on what are called embryonic stem cells. And the reason that that work was prohibited was because the way in which one would actually isolate those cells was by taking a very, very early embryo, a human embryo that was only 5 days old, 5 days post-conception, and then basically just destroying that embryo, taking the cells out and using them for therapeutic purposes. Is this 5-day-old embryo already an actual human being or not? And there were different perspectives on that. But that entire debate is over now, not because people have decided whether or not that embryo is really a human being yet, but rather because there's embryos anymore. We can create the same kind of cells without destroying embryos at all. A big discovery was made in Japan about 16 years ago now, that how to take regular adult cells from your skin, from the skin of an adult, and kind of drive their biological clock backwards so that they would become not exactly identical, but very similar to the same cells that we could previously only find by destroying embryos. We don't need to do that anymore. So that whole thing is over.
When you put in the stem cells and you put it in to treat something that can't reproduce those cells or has none of those cells left, is it easier for those stem cells to be effective if there are some cells left or no cells left? Like, does it have to have friends when it goes in or no friends? Talking about the skin, does that work for the whole body?
More or less, it doesn't need to have any friends. So essentially what you can do is when you drive this clock backwards, as I was saying, you end up with cells which are called induced pluripotent stem cells. What that means in non-technical language is they have forgotten that they were ever skin cells. They don't belong to any particular tissue. So then you can do what's called a redifferentiation process. You can drive them in a particular direction, which kind of recapitulates what a certain subset of those cells would have done during pregnancy, during the natural development of those cells in the early embryo, and they become what are called a lineage-committed stem cell. So they're still a stem cell. They are the type of stem cell that you want. So what we create in the case of Parkinson's disease is stem cells that will only become this particular type of neuron that we need, these things called dopaminergic neurons. There are other aspects to your question which are important. One really big one is the immune aspect. So we all know that when somebody needs a heart transplant or a liver transplant, they need to get that organ from a donor who is immunologically compatible, or otherwise it will be rejected, right? And of course, even then, you need very strong suppression of the immune system because there's only so much compatibility you can have. One of the dreams of this new way of doing things is that the stem cells that you give the person will be stem cells that were derived from that same person, from their skin, maybe, by this process of turning the clock back and then forwards again. That's what's called an autologous stem cell transplant. And then there's no immune reaction to speak of because the cells have the same DNA as the rest of the body.
What is your daily approach? What are you trying to do on a daily basis?
So I have two jobs, really. One job is scientific and one job is advocacy. So on the scientific side, I oversee a team of researchers, and I spend my time talking to a whole bunch of researchers who are not in my own team to try to optimize the research that's being done, to hasten as much as possible the development of these therapies that will repair these various types of damage. That's one of my jobs. The other job is to get money for them, basically. So the reason I do this interview, the reason I do an interview every day and I'm on stage every other day, is precisely because I want to educate the world that this is not a pipe dream anymore. This is not science fiction anymore. This is really coming, and therefore the sooner it comes, the better, because we'll save more lives that way and we'll alleviate more suffering that way. And at the end of the day, at the moment, we are still in the very unfortunate position where money is rate limiting. In other words, the science could go faster if it were better funded.
If you take the superfoods scenario of balancing your body, stem cells, and now you're going into this AI revolution and what's going on there, and I'm sure you see that in Silicon Valley. What's your interpretation of that?
My friend Ray Kurzweil has characterized the whole process. He says, there are these three bridges. There's stuff you can do already today, whether it's superfoods, whether it's supplements, lifestyle, diet. And then there's stage two, which is essentially my work, the development of biological new medicines that will be able to repair damage and keep the body going. And then he talks about bridge three, as he calls it, which is the merging of man and machine, essentially the improvement of artificial intelligence and brain-computer interfaces to the point where we don't really need to worry about maintaining the human body anymore because we can keep our consciousness, our personalities, our identity going with alternative hardware. So my take is this. First of all, with regard to Bridge 1, what we can do already, I'm very happy that there's so many people working on that. But I always have to make sure that people don't get over optimistic about it, because the magnitude of what you can get, how you can benefit from that, as compared to how long you would stay healthy and how long you would live if you just did what your mother told you and don't smoke and don't get seriously overweight. But other than that, you basically do what you like. I'm happy with people wanting to do that. But the fact is, it's not what I want to do. I'm aiming higher than that. So then bridge 2, well, as I say, Ray and I are on exactly the same page there. It's all about damage repair, regenerative medicine for aging. The question about bridge 3 is not really a technical question. We don't yet know whether we can do it. But the question really is, why would we bother if bridge 2 really works? Mm-hmm. If we can really completely control the damage that the body does to itself in the course of its normal operation, just in the same way that we can already do for a vintage car, then there's no limit to how long we can live healthily and youthfully in that state. And of course, other technologies are coming along all the time that are keeping us safe from other causes of death, self-driving cars, preventing road accidents. That's just one example. So maybe we just don't need uploading anymore.
That makes a lot of sense. I mean, if you're going to the AI space, maybe you're pushing a little too far?
Well, I wouldn't necessarily say it's too far. Subjectively, people may think today, they may think, well, I rather enjoy being made out of meat. I'm not really too keen on this uploading thing. But if you didn't have the choice, if Bridge 2 did not exist, right? So you only had the choice of either be uploaded or be dead, then you'd probably choose uploading, right? I mean, a lot of people would, maybe. So it's really, I'm just looking at the alternatives.
Is this something you've always been passionate about in early stages of your life?
That's a great question. Yes and no. I have always been absolutely clear in my mind, since early childhood, I would say, that aging is the world's number one problem. That it's the thing that quite obviously causes far more suffering than all other problems combined. It kills more than 2/3 of all people worldwide. But I was not particularly passionate about it. And here's why. The reason I wasn't is simply because I presumed that everybody else also realized that aging was the world's number one problem, and therefore there would be, large armies of biologists working on it. So when I was young, I didn't work in that area. I found when I was a kid that I was a good programmer, and so I thought, well, I won't work on aging. I'll work on another really bad problem for humanity, the problem of work. The fact that, people have to spend so much of their time doing stuff that they would not do unless they were being paid for it. Because the fact is, if we had better automation through artificial intelligence, we'd be able to solve that problem. Mm-hmm. And so I thought, that's what I'll do, because I'm good at programming. And I worked on that for a while. I did my undergrad degree in computer science, and I worked for 6 or 7 years as an artificial intelligence researcher. But during that time, I met and married a biologist, that same person I mentioned who spent her early childhood in Charleston. Through her, I began to find out that biologists were actually not thinking the way I was about aging. They thought that aging was rather uninteresting and unimportant. And I would say to my wife, why aren't you interested in aging? And she would say something like, well, it's just decay, isn't it? What fundamental truths about the universe are you going to find out by studying decay? And I would say, well, it's bad for you. And she would say, well, that's not my problem. And I would say, well, it kind of is.
Yeah.
And that would be about as far as we would get. And I would find out that it wasn't just her, that all biologists I was meeting took the same view, and indeed other non-biologists. I just had this enormous revelation that was just unbelievably mind-blowing to me, that nearly everybody in the world had just kind of forgotten about aging. So I thought, well, that won't do. And I happened to be in a very fortunate situation at that point in my life, so that I was able to switch fields. I was able to essentially create a whole new career for myself in my spare time, and here I am.
Do you have a vision for protocol in the future for what you're doing?
From the point of view of the person who gets this medicine, it will not actually look any different from today's medicine. Most of this will be administered just by injection, some of it even by oral administration, mostly injections. Possibly in the early stages, it will be necessary to do some surgery, but only in the early stages of the development of these things. That will be a temporary period. So basically injections, yeah. So I think it's likely that we will be injecting people with one injection that has 300 different medicines in it, not just vaccines, but also stem cells, maybe gene therapy, engineered viruses to alter our DNA. But from the point of view of who gets it, it won't look any different from today.
When do we introduce this? We probably don't want to wait till a guy's in his later years. Do we want to introduce this at a young age?
Great question. So actually, no. because this is damage repair, rejuvenation, and not stopping the body from generating damage in the first place, it does in fact make sense to start in middle age, like in 160, because by that time one's not yet sick typically, but one has built up a certain amount of this damage. So there is something to repair. So again, it's like a car. Going back to the car analogy, when you buy a brand new car, you don't need to take it into the garage for maintenance until it's maybe 5 years old, because until that time, there's just not enough damage to be worth repairing. And after that, you may take it in every year, but it's just the same.
And how soon do you think this will be accessible?
Yeah, I had a feeling you might get to ask that. I have to say, you don't sound particularly unimpressed by this. So of course I don't know. This is pioneering technology, and therefore any prediction of timeframes would be very speculative. But I'm not going to stop there. A lot of my colleagues, in fact, most of my colleagues who are experts on the biology of aging, are terrified of making any predictions at all because they so don't want to overpromise and underdeliver. But I feel that that's irresponsible. I feel that it's vital for experts to actually give predictions, even with that health warning about speculation, because otherwise you guys are just going to carry on believing that it's never going to happen, and that won't help, right? So I say that we have a 50% chance of reaching a decisive level of development of these therapies within the next 15 years or so. So what do I mean by decisive? I basically mean these therapies will by that point be comprehensive enough that we will be able to stay one step ahead of the problem thereafter, so that you can keep the same people youthful enough that they won't get sick, however long ago they were born. 15 years from now. Of course, that's a 50% chance. There's at least a 10% chance that we'll hit a whole bunch of unforeseen obstacles and we won't get there for 100 years. But who cares? A 50% chance is quite enough to be worth fighting for.
All right. In a perfect world, you start doing this at 60. How long will your life be extended?
So if you're 60 at the time that we reach this decisive level of development, there is no way that one can put a number on that, because it's just like a vintage car. Again, these vintage cars, they were designed to last 10 years. They lasted 100 years. If you'd gone back and you'd asked somebody 100 years ago when they were building such a car, if you'd asked them, what's the chance that any of your cars will last for 100 years? They'd have totally laughed at you. They'd have said, obviously, there's no way in the world that they'll last beyond like 20 years, any of them. But here they are. But now if you go and ask somebody who owns a 100-year-old car, whether that car is likely to be around in another 100 years, they'll say, well, of course it will. Why not? Because we just carry on doing the same maintenance, right? So exactly the same thing. If somebody is healthy enough at the time that these therapies arrive that they can be rejuvenated, even though the rejuvenation will not be completely perfect at that time, it'll carry on improving over subsequent decades. Nevertheless, they will never reach the level of damage in their body that would cause them to exhibit the health problems of late life, the chronic progressive conditions that we're familiar with. So that means that their risk of death in the coming year will be unrelated to how long ago they were born. And you can just look at the statistics, right? You can look at those numbers, and the answer is less than 1 in 1,000. So if you have that same probability of dying each year, less than 1 in 1,000, right, forever, then it's like radioactive decay. You're going to end up having a half-life, so to speak, of more than 1,000 years. And even that is a ridiculously conservative estimate, because that is determined by our current risk of death from causes that do not have to do with how long ago we were born. So in other words, it's completely ridiculous to put a number on how long people could expect to live if they make it to that point.
Being in Silicon Valley, do you see artificial intelligence as competition?
Certainly not. No, just the opposite. The mindset of people who work in these various pioneering technological disciplines is very, very similar. And we're all about the same thing. We're all about developing new technologies that have humanitarian benefit. So, for example, supposing that my work runs into the sand in a bad way and people who are working on uploading move forward really fast, and they end up getting uploading to work at a time when the boring, wet approach that I'm taking, actual medicine, is still not working, then I will be overjoyed that other people are saving lives, including perhaps my own life. Any self-respecting scientist or technologist feels the same way. It's not about personal achievement. It's not about glory. It's not about anything like that. It's about being part of the team. And exactly who gets there is completely secondary.
And is there other countries that have a little more leeway on this technology?
Kinda, but leeway is not everything. So, of course, what you're asking is regulatory hurdle. That's not really an issue. Here's why. why. The research that needs to be done falls into, well, a spectrum of stages. Early on, what's being done is we're just growing cells in a petri dish, or where, we've got mice in some kind of incubator that are just like being given this or that drug, right? The regulations surrounding those kinds of processes are not very different from one country to another. The only time when the regulations get to be very different from one country to another is in the later stages, when we're actually applying these things to humans and doing clinical trial, and whether the clinical trials can lead to approval of a drug to be actually prescribed. But by that time, kind of it doesn't matter where the work gets done. So if a company has some new therapy that seems to be really impressive and they need to go into clinical trials, and it's more difficult to go into the clinic in the US than it is in, Timbuktu, then they'll go to Timbuktu. The results will still be valid because there are human beings there and they still have the same kinds of bodies.
Well, I would imagine it's a very small room in the world for what you do.
What do you mean exactly?
There's probably only a few really, really good specialists that are behind this cause, and you guys all know each other?
Well, it depends how you define that community. So if you look at the community of people who would call themselves card-carrying biogerontologists, people who say that if you ask them what they do, they would say they study the biology of aging, then that's a relatively small community. Yes, certainly the senior people all know each other. But the relevant answer to your question is not that, because so much of medicine revolves around this. So, for example, I told you earlier about this new way of developing these very versatile stem cells, that you could take a stem cell from an adult and you can just turn it backwards. Now, that has relevance across the entirety of medicine, not only for medicine for the elderly. In fact, when I started to present the idea of damage repair as a viable approach against aging nearly 20 years ago, a lot of the resistance that I had from people who were working on the biology of aging was ignorant, because a lot of the science that I was starting from, that I was building into my proposals, was science that had been done by other types of biologists, people who were studying other things for other reasons. And of course, people who studied aging didn't know anything about that at first, and it took a while for them to catch up.
What do you do outside of your career? Do you go out in nature? You go hang out? What's going on?
I wish I could. I mean, life's too short right now. I'm investing in my future by getting this done so that I will have plenty of time to do what I want later on. I'm very privileged. I live in a lovely place in the mountains south of Silicon Valley, so I have a lovely environment. But at the end of the day, that's not the only way in which I'm privileged. My biggest privilege is that I'm the global spiritual leader of this longevity movement. I think it's fair to say that I'm probably the single person in the world who is making more difference to the date at which aging is medically controlled. And, that's what I've always wanted, to spend my life working on the most severe problems for humanity and making as much difference as I can. So I have the best job in the world, but as I would measure it. And not many people can say that.
Is there a correlation with what you do in spirituality?
Not at all. No, I didn't really mention spirituality. I just called myself kind of, frivolously a spiritual leader of the movement. That people kind of sometimes behave a little bit as though they worship me. But I was purely joking there.
Oh, okay. Because there's not a lot of people that have this gift to be able to think like you do. And there's something kind of pushing you in a certain direction, and you're always ending up where you're ending up today.
Sure. I mean, of course, everybody has their own strengths and weaknesses. I don't think I'm uniquely, gifted in any particular way. I think I have an unusual level, not a unique level, but an unusual level of quality in various different ways that combine to make me very effective. Certainly, I'm a good scientist, a good technologist. I'm also very determined. I'm also reasonably charismatic, I guess. I'm thick-skinned, which is certainly important when you're in a minority. So I combine all of these things and I get stuff done. As with anyone who's trying to be a pioneer, trying to make a big difference, the single number one thing that determines whether or not they do is luck. Just being in the right place at the right time. I might not have married a biologist in 1991.
Well, I don't know. Preparation meets opportunity.
But certainly for my formative years, it was all purely that way.
Well, and thick skin, I'm sure, it's just like in the entertainment business, when we try to create a project or whatever, and you're very, very excited about that project, and you go present that project, and like, whoops, no. I can understand that. Having thick skin is a big deal.
Yeah.
Very big deal. I think it's exciting for the future, and I hope your 50-50 deal happens. That would be great.
Thank you for having me on the show. I do a great deal of media, and the reason I do it is because every time I do an interview, I'm reaching a new audience and raising the quality of people's understanding of where we are in this and how soon we might actually be able to finally solve humanity's most serious problem.
How about the hair up here? Will you give me some sales for some hair?
Yeah, we can already do that. It's
Oh,
expensive
okay.
so far, but
Oh,
yeah, we
really?
can do that.
How much is the hair going to cost me?
Well, remember, it's not me per se. We do research, so we don't sell anything. But yeah, those therapies exist.
Oh, okay, cool. This has been Dr. Aubrey de Grey. He's the specialist in aging with stem cells and so forth. Amazing what he does, and I wish him the best. And I don't know, is there anything else you want to say in closing words?
Well, sure. The big question you have not asked me is, where do I send the check? As I mentioned at the beginning, funding is rate limiting for all of this. It is slowing things down. We are a charity, so, you can put the website in the chat. We have a huge amount of material for every kind of audience, from, absolute experts all the way through to complete novices. There's a contact form. You can ask us any questions you like. We're very well behaved at answering those. So, yeah, that's what I would recommend people to do.
Yes, I mean, if you are interested, it's SENS, SENS.org, SENS Research Foundation, right?
Exactly.
Is correct. If you're interested in what the doctor is talking about, I think it is the future, and he's definitely on to something very, very good for the human life, if you will. Like I said, when you're in Charleston, let me know. Love to have you in person. This is Edmonds Kozma, the CEO of Bang Productions.